All right, we're doing a curve sketching problem here from the chapter 4 review. 1 over x times x minus 3 squared, that's all on the bottom. It's a rational function, and we know a lot of things just without doing any calculus even. I'm going to do one thing though really quick. I'm just going to kind of think of this a slightly different way for the derivative. I could do a quotient rule here, but since there's just a constant on top, I'm thinking I might write it as x to the negative 1 x minus 3 to the negative 2 for the purposes of doing the next derivative, just like or of the derivative at all, or both derivatives, and then kind of factor those. I just feel like that might be a little simpler for me anyway. You can do it however you want, though, obviously. Shrink all this up a little. I am going to kind of work, though, from this form for just thinking about the function to begin with. So first thing I want to do is domain. And there are some domain breaks at 0 and at x equals 3. And those are both vertical asymptotes, right? So the domain, I'm going to say all real numbers except x cannot equal 0 or 3. And, just kind of point out vertical asymptotes at those two values, x equals 0, x equals 3. Also, if I'm thinking about like a sign chart on just f, not that you necessarily have to do this, but I will not get a sign change as I cross that vertical asymptote because it has an even power. I will get a sign change as I cross that one. So I could make a note of that if I wanted to, or I could just do a really fast sign chart because I kind of already see it happening. The only zeros of any factors here are the 0 and the 3. So since I can just do it quickly as I'm seeing it, my thought is as x is a large positive value, those factors will all be positive. So the whole thing is positive over here. No sign change at 3 because of the even power there. So as I go from like 3.01 to 2.99, while the inside of this changes signs when you square it, it does not. And nothing else is going to change signs there. So that'll still be positive. And then off to the left, it is negative because you do get a sign change at 0. You can list out factors and do a sign chart that way if you like. You don't even have to do a sign chart on f if you don't want to, but it could be helpful for the graphing. So we got the domain. We got the domain breaks there classified as vertical asymptotes. And then I also want to consider the end behavior here. So here, I'll just label that end behavior. And there's a horizontal asymptote here. You may remember from pre-calc algebra 2 even, when you have a greater degree in the denominator of a rational function, you're going to have a horizontal asymptote at y equals 0. And it makes sense too. If you just think about big numbers for x, the denominator gets very large. And so you have 1 over a large number. And that's true in both the positive and negative direction. In the negative direction, it'll be a large negative number, but still the point is it's close to 0. By the way, that fits with this sign chart. When you plug in a large negative number for x, we get a 1 over a large negative number, which is a very small magnitude negative number. Close to 0, but negative. All right, so limits. The limit as x approaches negative infinity of f of x and positive infinity, both are going to be 0. I'll just put a plus or minus here to save space and writing. Equals, what did I say, 0? Yeah, that's a horizontal asymptote. H-A y equals 0. You don't necessarily have to, I'm saying some things a couple different ways. You don't necessarily have to say them all these ways. Depends on, obviously answer whatever questions are asked. And then aside from that, if you're sketching a graph, identify the details that are useful to you. Here, I'll make all this blue since it was all from F. Now I'll switch colors. So f prime, and I could probably sketch a decent graph just from what we've got so far. By the way, there are no zeros. I didn't mention that, but the numerator can't be 0, right? So no zeros. We could find the y-intercept. Well, we can't, right? If you plug in 0 for x, you get that's on the vertical asymptote. So that's it. Really nothing else there. I mean, you could find some anchor points, but I don't think we necessarily need to. All right. Figure out what points are important here. So f prime of x equals we've got a product rule now. I avoided the quotient rule by writing it this way. So negative x to the negative 2 times x minus 3 to the negative 2 plus, well, it's going to be minus, right? So why don't I just go ahead and do this? Minus x to the negative 1 times, negative 2. That's where the minus is coming from. Here, let me kind of sneak the 2 in front there. And then x minus 3 to the negative 3. And then times the derivative of the inside, which is just 1. So nothing to worry about there. And I'm going to go ahead and factor out an x minus 3 to the negative 3 because that's the lesser of these two powers. And I'm going to factor out an x to the negative 2 because that's the lesser of these two powers. And while I'm at it, I'll make it negative since both terms are negative. So negative x to the negative 2, x minus 3 to the negative 3. And what's left? Well, from this term, that factor, from this term, we took out the entire negative x to negative 2, and we just get one of these, right? X minus 3. And then we took out the negative x, we took out that stuff, right? Negative x minus 3 to the negative 3, that's this. And what's left here is 2x from this part, right? So plus 2x. Take a look and just kind of think it through if you're not sure. If you distribute the negative x to the negative 2 to this term, it gives you the negative 2x to the negative 1. And then, of course, this part gives you the x minus 3 to the negative 3. So those are equivalent. And then I'm just going to kind of simplify in here. That's 3x minus 3. You can actually factor out the 3 while you're at it. Equals negative 3. And that's going to be, I'm going to put this factor next, x minus 1. Don't have to factor out the 3 if you don't want. And then I'm just going to put these on the bottom now. X squared, x minus 3 cubed. Okay, so that first derivative is, it's got a bit going on. And that's going to make for a slightly annoying second derivative maybe. That's okay. Not too bad. There's a quotient rule with a product rule in the denominator maybe. Or I could do this and do like a, with this simplified and do like a double product rule. Anyhow, start with f prime though. We've got f prime, and now we want to look at where f prime equals 0 or does not exist. So f prime equals 0 when the numerator equals 0, that's only at x equals 1. And so, yeah, that's going to be a horizontal tangent. And then f prime dne only at the two domain breaks, right? 0 and 3. I am going to write them down. Those are not critical numbers though, right? If you're asked to give critical values or critical numbers, this is the only one that's a critical number. So critical point at 1 comma f of 1. And if you plug 1 in, you get 1 times, on the bottom you get negative 2 squared, which is 4. So it's 1/4 for the y value. And that's going to maybe be a max or min. We'll do our sign chart in a minute here and just kind of verify. I said that's the only critical point. I want to be really clear about this. You can have critical points where a derivative does not exist. The reason these are not critical points is because they are not in the domain of the function. They are vertical asymptotes. So it can't be a critical point if it's not a point, right? So you definitely want to always consider all of these for critical points, but if something's not in the domain, you leave it out. You don't call it a critical point. That's all. All right, quick sign chart here for f prime. We've got 0, 1, and 3 on our sign chart. And we got that negative 3 factor. Just watch that. So that's going to change the sign on everything. And again, you can kind of list factors down here and do a little sign chart on each one separately and then put them together if you like that. I personally, something like this, it's not too complicated, right? I got one factor to the third power, one to the second power, one to the first power. So I'm just going to think to myself, if I plug in a large x value, a large positive x value, so way out here, positive, 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 negative. So it's going to be negative out there. Oh, by the way, I should label those, right? I said 0, 1, and 3 are those key numbers there. And then do I get sign changes? At 3, I do because that has an odd power. At 1, I do because that has an odd power. It's just the first power. At 0, I do not because that has an even power. Whoops, I was about to write plus, but that should be minus. Okay, so that's my sign chart on f prime. And so that critical point at 1, 1/4, that is indeed a relative minimum, right? Because f prime changes from negative to positive. Again, if you're trying to justify statements like this, you should say f of x has a relative minimum at 1, 1/4 because f prime of x changes signs from negative to positive there. Cool? All right. That's my whole analysis on f prime. Let's go to f double prime. Let's do this up. And you know what? I already did a product rule on f to get to f prime. I kind of changed it into a product rule. I've got this written this way. I'm tempted to just go with product rule again, right? And if you kind of think, let me write it one more time. This is, again, negative 3 x minus 1 x to the negative 2 x minus 3 cubed, right? Whoops, not cubed, to the negative 3. And so if I want to do the double product rule, I can do that. What I mean by double product rule is, the product rule is derivative of uv is u prime v plus uv prime. If I have uvw, then it's uvw, then it's going to be u prime vw plus uv prime w plus uvw prime. And that might be easier, I don't know, than the product rule and the quotient rule. You could go either way. Really doesn't matter. Personal preference. If I do the product rule, we're definitely going to have a little factoring, kind of like we did here with the up here with the negative powers and stuff. But I kind of like that. So f double prime of x equals, and yeah, I'm going from here. The derivative of the negative 3 times x minus 1, if I put the negative 3 with it, is just negative 3. And so we'll have x to the negative 2, x minus 3 to the negative 3, and then plus, but the next one's going to be negative 3 times this, times the derivative of this, which will also be negative. So that actually will be a positive, and then times this. So it's going to be negative 2x to the negative 3, right, from this guy, times this guy. So negative 2 times negative 3 is plus 6. So plus 6, and I'm going to have that x minus 1 factor, and x to the negative 3, and again, x minus 3 to the negative 3. And then I've got plus, and here we have this whole factor, right? Once again. And then we got this whole factor. Now we want the derivative of this one. So it's going to be negative 3 times x minus 3 to the negative 4. So that negative 3, when I bring it out front and multiply it by that, is going to be a positive 9. So it's going to be plus 9 and x minus 1, x to the negative 2, and then x minus 3 to the negative 4. And again, I'm thinking about the derivative of the inside for a chain rule. It's just 1, so it's no issue. I'm having trouble writing that 4. Let me try that again. All right, so that's that. And then I want to factor. So I'm going to take out a GCF just like I did before. And I could take out a 3 for sure. And while I'm at it, I can take out an x to the negative 3 and an x minus 3 to the negative 4. Again, take the lesser of the powers. That way we'll leave positive powers in what's left. So from the first factor, what did I have there? Well, we took out the 3. We took out an x to the negative 2. So that leaves a negative x. And we also have an x minus 3 factor there. Because we took out x minus 3 to the negative 4, and that's negative 3. All right. From the second term, we took out a 3, so we're going to have plus 2. 3 times 2 is 6. We need that x minus 1. We didn't factor that out. And then we factored out the x to the negative third. And we only factored out an x minus 3 to the negative fourth. This is 1 degree higher, so we'll have another x minus 3 there. Okay, and then finally, this is kind of a lot of work on this guy. I wonder if that quotient rule would have been easier. We took out a 3. There's a 9, so there's a 3 left. We did not take out the x minus 1, so there's x minus 1. We took out an x to the negative 3. This is an x to the negative 2, which is 1 higher, so we get an x from that. And we did take out this whole thing with that GCF. So that's all of it. And what I'm going to do is just do a little quick kind of simplification here. So this is negative x squared plus 3x. This is plus 2x squared. And then I got a, negative 3x, and a negative x is a negative 4x. So negative 4x times 8 is going to be minus 8x. And then plus 3 times 2 is plus 6. And then we have a plus 3x squared, and we have a minus 3x, right? So now we can put all of that together. 3x squared plus 2x squared minus x squared, that's 4x squared. 3x minus 8x, that's negative 5x, minus 3x is negative 8x. And finally, plus 6 is what's left there. While I'm at it, I suppose I could just factor out a 2. And so that second derivative is, take out a 2, 6x to the negative 3. You know what? Let's write it in fraction form here, rational function form here. 6x to the negative 3, x minus 3 to the negative 4, right? So it's on the bottom. And then on top we have this quadratic. We factored out the 2, so it's going to be 2x squared minus 4x plus 3. And could I have factored that more? Multiply to give me 6, add up to negative 4. I don't think so. So quadratic formula probably on that. Here's real quick here. X equals negative b plus or minus a square root b squared minus 4ac. It's going to be minus 24. That's an imaginary number, right? Complex. Not real, importantly. So all over 2a. And so this has no real solutions, this numerator. It means it's f double prime, excuse me. F prime does not equal 0 for any x value. Here, let me write it a different way. F double prime equals 0, no real solutions there. Specifically, we're only looking at real stuff here. And then the other things, the only solutions here are just the ones we already knew about, 0 and 3, those vertical asymptotes. So you don't have to make a big deal out of them. We can just do a quick sign chart again. And we got 0 and 3 and f double prime. And again, you can list them, or this is always positive, right? It's an upward opening parabola. It has no real zeros. That means it's got to be above the x-axis. So the whole thing is positive off to the right. And then when you cross 3, that's got a positive, an even power, so it's not going to change signs there, but it is going to change signs there. And so there we go. We have intervals of concavity. F is concave down from negative infinity to 0, concave up from 0 to 3, concave up from 3 to infinity. You don't want to put these together in one interval because there's a vertical asymptote in between. So those are two separate intervals of concavity. And generally with intervals of concavity, you're giving open intervals. So if you were giving this, you'd say f concave down, negative infinity to 0, and up 0 to 3, and also 3 to infinity. And I think best practice here is to use a comma to separate those and not the union symbol. because they're two separate intervals of concave upness. You don't want to concave uppity. You don't want to like act like they're together. The union symbol acts like it's a set of numbers across two intervals that are kind of concave up together, and that doesn't really work. So you want them separate with comma. Same thing when you give intervals like that of increasing and decreasing if they're broken up somewhere, even if you have like two consecutive increasing intervals. All right, so now we're ready, I think, to try to graph this thing. And again, we probably could have got a decent graph without doing any calculus, just by using the asymptotes that we know. We have a horizontal asymptote at 0. We already off to the right, we're approaching it from below. We talked about that. You could tell just from a sign chart on F. And off to the right, I'm sorry, I meant off to the left there. I don't know if I said that correctly. Off to the right, we're approaching from above. And then there are vertical asymptotes at 3. I'll put that right here. That's 3. And at 0, put that right there. And again, we know, I just did a quick sign chart on F, which can be helpful. We know we're above the x-axis the whole way from 0 to 3. And then we're also above from 3 to infinity. So that would tell me that we're probably doing this and this. And then somewhere in here, we're going to have a minimum. And we saw that in F prime. That's one thing that does tell us, is exactly where that minimum occurs. And then again, if we're positive over here, we're going to have to be up here, right? We have all this evidence that goes together. That's why I'm not finishing the graph yet. I kind of want to show you that aspect. We're below the x-axis all the way here, which tells me we must be going down on this side of the vertical asymptote. Couldn't possibly be up, because that would not be true then. So, I mean, you can kind of tell what this graph does. It's obviously it's going to do something like that, and like that. But more detail. We know we have a relative minimum. Oh, I kind of moved that at 1 comma 1/4. So I'll put that point on there. Here's 1 and 2, since that's 3. And I'm just going to put like 1 up there, and it's at 1/4. So it'll be there. And so that's good. I'm going to just kind of come down. This has to be pretty close there to make this work. And, I've got it labeled over here. This is important. You could, I could just do this. I don't want to mess up the rest of my graph here, but I could kind of point this out, I suppose. Here, let me use like a different pen type here for it. Relative min. If I want to be very thorough, I mean, we've put so much work into this, right? May as well make it look good. And then the rest of this, I mean, there's no like points of inflection. We do have changes in concavity, but they're not inflection points because they're just at the asymptotes. And so, I mean, we could plot like anchor points over here somewhere and over here somewhere if we wanted to get a little more precise. But I think, that's not really the point here. We are concave up out here. We're above the x-axis and we're decreasing. So it's going to look something like that. And we know we're approaching 0 from above. All of that fits together, right? We have to approach those asymptotes. We have to be decreasing, and we have to be concave up, and we have to be above the x-axis. All of those pieces fit together. If one of those was off, it could make this like not work, right? So it's a good sign when everything sort of fits. Same thing down here, we're concave down, we're under the x-axis, and we're decreasing that whole way, right? Decreasing, negative, and if you go down to that sign chart on F double prime, concave down. Make sure that I'm not lying there. Yep. Okay, and so, yeah, all this just, it fits. That's what the graph looks like. That second derivative was a fair bit of work algebraically for something that we probably could have done without it. But, that's the way it goes sometimes.